360-degree cameras for cost-effective data collection. 360 cameras, also commonly referred to as panoramic cameras, are cameras designed to capture a 360-degree view around the camera, as opposed to the typical 2D forward-only view captured by a traditional camera. 360 cameras typically have two or more lenses facing different directions to capture a full 360-degree view of the camera's surroundings. These cameras are commonly known for capturing street view style imagery. Despite their association with street view, many smaller, compact form factor cameras exist, making them ideal for capturing data far beyond the roadway. 360 cameras permit shoot first, point later functionality, are easy to deploy, highly portable, cost effective, and support both active and passive data collection. With traditional cameras, you must know what you want to take a picture of ahead of time. 360 cameras capture your entire surroundings. You're no longer limited to capturing what you know and see, and instead can focus on where you want to capture rather than what you want to capture. For inspections and other operations where capturing the right information is critical, this can mean the difference between a return trip to the field or simply navigating imagery without ever needing to leave the office. While UAVs are widely used for aerial data collection, they're not without their limitations. Aside from the cost of required hardware and software, UAVs required skilled, licensed pilots and strict compliance with federal, state, and local regulation. In addition, there are many cases where an aerial platform simply isn't a reasonable option, such as enclosed spaces, areas with overhead obstructions, or flight-restricted areas. To make matters worse, any kind of inclement weather can completely derail UAV operations. In contrast, 360 cameras are small, highly portable, not subject to any meaningful restrictions, and typically water and weather resistant. This makes them well suited for use in a wide variety of circumstances, especially when aerial platforms are not a reasonable option. Many of the most popular 360 cameras will easily fit in a pocket or small bag. This makes it easy for field personnel to always have the necessary equipment on their person or nearby. A 360 camera is effectively a pocket-sized geospatial data collection platform. Gathering information about a site or resource can be as simple as pulling out your 360 camera and walking around. With a starting price of about $300, 360 cameras are a cost-effective solution for imagery and data capture. At the $500 price point, a wide selection of options are available to suit the needs for most field data collection scenarios. This makes it possible to consider equipping field personnel with these cameras for use on an as-needed basis. Many 360 camera platforms have their roots in active lifestyles and extreme sports. They are rugged, weather-resistant, and designed to be held, worn, or mounted while performing a variety of activities. As a result, they are well suited for the rigorous lifestyle of field workers. They can be carried, worn, or mounted. In passive data collection scenarios, field workers can go about their regular duties while allowing the camera to capture their surroundings. This data can later be used for documentation, data extraction, or for further inspection, potentially eliminating the need for a return trip to the field site. Some example use cases for 360 cameras are capturing data for inspections, reconnaissance, documentation, asset management, site conditions, driveways and line of sight, landslides, roadway conditions, erosion control devices, property information and boundaries, construction sites, and facilities. A variety of different cameras are available to suit your data collection needs. The GoPro Max is a compact, durable, and water-resistant 360 camera built on the popular GoPro platform. The Insta360 One X2 is a compact entry from Insta360, who focuses exclusively on 360 cameras. The RICO Theta is a compact entry from RICO that is available in a wide range of feature sets and price points. The Insta360 Pro 2 is a high-end professional-grade camera promising high-resolution, long-range control, and 3D stereographic capture. Though not exactly fitting the cost-effective label, the Pro 2 is indicative of some of the higher-end options available. A variety of mounting options are available, including backpack, monopod or selfie stick, tripod, helmet, vehicle mounts, and handheld. To make the best use of 360-degree imagery and videos, special software packages are required. In cases where data privacy is not a concern, crowdsourced solutions are available. Some of the pros of these crowdsourced solutions are low or free cost, high service reliability, robust tooling, and the fact that data for the area of concern may already exist. Some of the cons for the use of crowdsourced solutions are that the imagery is typically public, your processing is at the mercy of the platform, platform and API changes may break existing workflows, imagery may be used for alternate purposes such as feature identification through artificial intelligence. You have little to no control over tooling and functionality, and your hardware must be compatible with their solutions. Here we can see the Mapillary add-in for ArcGIS Pro. In this view, the data pictured was captured at the Salzburg Trail Access on the Westmoreland Heritage Trail in Westmoreland County. In cases where crowdsourced solutions are not a reasonable option, custom development solutions are available. Some of the pros of custom developed solutions are that the data is private, you have complete control of processing, system changes, etc. They're highly customizable, and then tooling can be tailored to hardware on hand. On the other hand, they're often more costly than crowdsourced solutions and require existing infrastructure for storage and hosting. In this example, we are using ArcGIS Enterprise to host and view our 360 images. For viewing and navigating the images, we will be using a custom panorama viewer widget. This widget allows us to both navigate between images and pan around each image to focus on areas of interest. Using the widget's tooling, we are able to focus on items of interest even as we move between images. By taking advantage of the positioning and directional information provided by the images, we are able to identify key features in our imagery, which can then be collected to a feature class if desired. The 360-degree view across multiple images provides us with multiple perspectives on a location or asset, which can be very useful for identification or inspection. The full screen capabilities of the panorama viewer make it easy to identify features at a higher resolution. The Panorama Viewer widget is a feature-rich custom widget developed by Nodeology for use in ArcGIS Enterprise and ArcGIS Online. The widget and corresponding tools were designed for simplicity of use while supporting common use cases and workflows. The data collection and processing workflow is a simple and straightforward operation that virtually anyone can execute. Most 360 cameras are designed to be very easy to operate. Once the data is collected, images are copied to a computer and uploaded to ArcGIS Online or Enterprise using a Python script tool in ArcMap or ArcGIS Pro. The images are added to a point feature class with the images as attachments. 360 imagery is useful for a variety of purposes within GIS, including imagery analysis, object identification, feature extraction, site evaluation, object inspection, site recon, and much more. In the hands of a geospatial professional, 360 imagery is a valuable tool that serves a wide variety of needs in the enterprise. Some of the features that can be expected in the near future are direct feature extraction from imagery, artificial intelligence and machine learning for automated feature recognition and extraction, standalone and portable viewers, and ArcGIS and Enterprise and Online widget improvements. In summary, commercial off-the-shelf 360 cameras are a cost-effective, highly portable, easy to operate and versatile data collection platform that allows organization to put imagery and geospatial data capture functionality in the hands of inspectors, engineers, and field personnel with minimal cost and effort and little regard to environmental conditions, regulations, or other restrictions.